Assalamu alaikum wa rahmatullah wa barakatuhu. Dear students, I welcome you back to the course Innovation to Network and Security, code ITNW 4109. My name is Mubashir and I'm from UTAS IBRI. So, students, today we are going to understand about lecture number 11, which is about NFV security. NFV stands for Network Function Virtualization Security. Students, in the earlier part of the course, we discussed about SDN. SDN decouples the two functions, data plane and control plane function. We already discussed that in SDN approach, control function decide the route of the traffic and relative priority of traffic, whereas data function forwards the data based on control function policy. Further, students, we discussed how to secure SDN. Now, in the second part of the course, we discussed about NFV, network function virtualization, that decouples the network functions like switching, routing, firewalling, IDS, IPS from the proprietary hardware platform and implement these functions in software. Now we will discuss how to secure NFV. Now students, at the end of the lecture, you should be able to define and understand about NFV security, the attack surfaces, and ETSI security perspective. ETSI students stands for European Telecommunication Standard Institute. It is an independent, not-for-profit standardization organization in the information and communication technology industry. It fulfills all the European and the global market needs. Then students, we have to and you have to understand about the hypervisor introspection. Hypervisor we already discussed in our past lectures. It is also known as Virtual Machine Monitor, VMM, and it's a software that creates and runs virtual machines. We already discussed that hypervisor allows one host computer to support multiple guest virtual machines. So one physical machine can host multiple guest virtual machines by virtualizing and sharing its resources, such as memory and processing. So at last we discussed about the hypervisor. There are two types of hypervisor: type 1 hypervisor and type 2 hypervisor. In the last students, we will discuss about the security techniques. So these are the objectives of our today lecture. Okay, now students, let's discuss about the NFV security. NFV dramatically changes how networks are designed, built, and managed. NFV moves the network functions and network associated functions, like we already discussed, like switching, like routing, from the proprietary hardware and place them on the virtual machines over here in the virtual machine. Here is the virtual machine monitor, and on the server that can be deployed where needed within the physical network environment. Now, students, the security challenge with network function virtualization is that it increases the attack surface and increases security complexity. Explain why? Because earlier it was in the closed proprietary. Now it's on the virtual machine. So the attack surface is increased more, and there are more challenges in NFV because it's on the virtual machine. In contrast to the traditional hardware-based networks, okay, NFV make defining and administering security roles more complex because there can be, you can say, bypassing the authentication process. That can be exploited by the remote attackers over the network without needing to authenticate on the device. So now students, we will discuss about the attack surfaces. Attack surface is the sum of all possible security risk exposures. It can also be explained as the aggregate of all known, unknown, and potential vulnerabilities and control across all hardware, software, and network components. I will explain later these things on the slide, next slide. I just make a drawing graphically. I will explain it inshallah. Whereas students, the attack vectors are the methods that the enemies or your rival use to breach or break into your network. So attack vectors take many different forms, ranging from the malware, ransomware, to man-in-middle attacks, compromised credentials, and phishing. All these are the example of the attack vectors. Some attack vectors target weaknesses in your security and overall infrastructure. Other target weaknesses in the human that have access to your network. And let's see diagrammatically. So student, here is the horizontally your devices and application on the network like your server, storage, router, switches, Wi-Fi, and in our case we have our network function virtualization hosted on the virtual machine monitor, and on the vertical are the attack vectors. Okay, weak passwords, shared password, malicious insider, man-in-middle attack, phishing, social engineering, spam. So students, keeping the attack surface as small as possible is a basic security measure. Okay, now students, let's understand the attack surface more logically. The figure shown on the right side, it shows the potential NFV attack surfaces from a logical point of view. So you can see in the diagram, here is your host machine, the hardware, your host machine on the top after the hardware hypervisor, and then on the hypervisor we have the VNF. VNF student basically virtualized network function. Actually, it is responsible for handling specific network function, like we discussed before. One VNF, it can contain a switching, routing. The other can take about firewalling. So, and VNF is responsible for handling specific network functions that run on one or more virtual machines. See? So, the design of insufficient set of security mechanism and policy is complicated by the fact that the different parties may operate at each of the levels. Okay. So students, a key concern, security concern for the system administrator is to control which user or system can view, set, or change configuration parameters and can affect the network policy. Therefore, the security requirements needs to take into the account. Okay, now let's see what is ETSI security perspective. It means how they view about the security. ETSI we already discussed in the first slide. it is the European Telecommunication Standard Institute, and it's an independent, not-for-profit standardization organization in the information and communication technology. And it is a leading organization in developing the NFV standards, and they have issued so many documents. The documents that relates to identify new security vulnerabilities resulting from the NFV, and it also aims to catalog security features in management software relevant to the NFV. Uh, Now, students, we will see in the diagram on the right side, figure 16.6 over here, that how NFV threat is addressed. Student, on the left side, you can see here that generic virtualization threat, for example, the threats that are faced by any virtualization implementation, such as failure to isolate the guest user. Okay, one is the user of in which the organization user are. Okay, the employees working in the organization, and the guest user are not the employees that are working in the organization. It is outside users. So I repeat, the generic virtualization threats, the pink color over here, these are the threats faced by any virtualization implementation, such as failure to isolate the guest user. The blue color, light blue over here, it is generic networking threats, like the threats specific to the system of physical network function prior to the virtualization, for example, the denial of service attack, firewall breach, or bypassing the authentication. Okay. So here the pink color, it's a virtualization threads, okay, and blue networking threads. Now let's come to our this side inside gray color. This is the our NFV specific threats, students here. The threats that arise with the combining of virtualization technology and networking technology. Okay. So we need to mitigate these threats. It means reduce hypervisor mitigated threats to reduce to lessen these threats. So students, the generic virtualization threat, generic networking threats, and NFV specific threats, as I explained earlier in the previous slide, it is given here in detail. So you can read yourself. Now, students, let's focus on this part. This is our part. So what are the example of NFV specific threats? Okay. So the first example is that the use of hypervisor, actually, students, may introduce additional security vulnerabilities. In general, to reduce the vulnerability of hypervisor in use, it is essential, it is important to follow the best practices on hardening and patch management. The second example is that the usage of the shared storage and shared networking may also add additional dimension of vulnerability, obviously. So the extension of the diverse VNFs over the VNF infrastructure can also create additional security issues, in particular if VNF are not properly isolated from others. So now students, the example we discussed on the previous slide for NFV specific threat example, here are they in more details. Now students, when we talk about the hardening, because we have already discussed in the previous slide, to reduce the vulnerability of hypervisor, it is essential to follow best practices on hardening. Actually, hardening, student, is the process of securing system by reducing its surface of vulnerability, which is larger when system perform more functions. In principle, a single function system is more secure, than a multi-purpose function. Whereas student, the patch management actually is the process of distributing and applying updates to the software. So these patches are often necessary to correct the errors. And in our case now here, when a vulnerability is found after the release of a piece of software, a patch can be used to fix the vulnerability. So some other examples are here, like the use of shared storage and shared networking may also add vulnerability. So example, like in Windows platform, we use virtual hard disk in storage area network. So it can increase the vulnerability. So it weakens your security. So the next is the interconnectivity among NFV end-to-end architectural components. So student, let's diagrammatically let's see, because it also exposes. So here is it. If we have one NFV, let's assume, for related to the switching, here, one NFV, and the other one related to the routing. So they say the interconnectivity among the NFV, okay, within hardware resources, okay, it exposes the new interfaces that, unless protected, can create new security threats. So need to protect the interfaces among different VNF, among different VNFs. So all the interfaces has to be protected. So the execution of the diverse VNF. Diverse means when one side we have IDS, IPS. On the other side we have routing. Okay, diversity is there. It also create additional security issues. If VNF are not properly isolated from one another, it can create a new security threat. Okay, now students, we will discuss about hypervisor introspection. Actually, the word introspection, first of all, let's understand what is the concept behind introspection. In general, introspection is the examination or observation of mental or the emotional processes. Sure. And actually, when we talk about hypervisor introspection, so hypervisor introspection, not all hypervisor activity is hidden from the guest virtual machines. And the guest virtual machine can detect when the hypervisor perform an action on guest virtual machine. So the virtual machine introspection can monitor, can check. We call this technique hypervisor introspection, that how malicious insider could utilize this technique to avoid passive virtual machine introspection system. So students, this ETSI, they make some observations. What observation? That virtualization can eliminate, can finish some threats. It can eliminate some threats, uh, or and it can reduce, mitigate some threats, which is inherent, which is built in to non-virtualized network function through the use of the hypervisor introspection and some other techniques. But we will focus on the hypervisor introspection. So hypervisor introspection is the hypervisor capability to monitor, okay? Because monitoring is here going on. Something is watching. So monitoring each guest operating system or each guest virtual machine as it is running for the security purpose. So hypervisor introspection has become a common security technique in the virtualized environment. So Uh, Hypervisor-based introspection can help detect attack on virtual machines and guest operating system, like I discussed earlier, even when the guest operating system are tampered with. So, student, let's take a. I put a diagram, small diagram here. This is one virtual machine on the left side, and this is the other virtual machine on the right side. Two virtual machine on one physical host machine. Okay, above the virtual machine monitor, above the hypervisor. So virtual machines, it has a user mode, it has a kernel mode, it has a memory, because inside the memory we have a user mode and kernel mode. So this user mode, kernel mode, a malicious action can be taken on the user mode and kernel mode. And a memory, introspection is through a monitoring of memory, program execution, and access to data file and the network traffic. So in hypervisor introspection, it can in particular thwart kernel level rootkits. So what is kernel level rootkits? These are the rootkits which operate at the kernel level. At the kernel level, it means the kernel is the core of the operating system. We know that, and have a serious effect on the system. So these rootkits are usually difficult to detect since they operate at the kernel, meaning they have the same privileges like that of the operating system. Okay, now students, let's go for the security techniques. The NFV environment classify into three functional domains, which is given below. Okay, so let's first of all analyze the diagram here. So student, the diagram over here, it contains first of all the NFVI. So NFVI stands for Network Function Virtualization Infrastructure. Actually, it is the totality of all hardware, software components that build up the environment in which VNF are deployed. VNF for the switching, VNF for the routing. So the NFVI can span across several locations, different locations, and the network connecting provides the connectivity between these locations. It is considered to be the part of NFVI. So student, here they mentioned the three domains. You can see here the hypervisor domain, compute domain, and the infrastructure domain. And in each you can see, let's understand what are these domains. So in the compute domain, it provides the you can say a commercial off the shelf high volume server and storage when we talk about compute domain. But when we talk about hypervisor domain, it facilitates the resources of the compute domain to the virtual machine of the software appliances, providing an abstraction of the hardware. Whereas the infrastructure network domain, it comprises all generic high volume switches connected into a network that can be configured to supply a network infrastructure services. So students, you can see here, you can observe that the when we talk about hypervisor domain, because it is related to virtualization, so virtual computing and virtual storage is the part because of the hypervisor domain. But when we talk about compute domain, as I discussed you earlier, high volume server and storage are there. So computing hardware and storage hardware is the part. But when we talk about the infrastructure network domain, so it comprises all the generic high volume switches that are interconnected into a network that can be configured to apply infrastructure and the network services. So that's why virtual network and virtual hardware is there as a part. So now students, let's see the security techniques. we will discuss again about the hypervisor domain, then what are the security risks at the hypervisor domain, and what are the solution to avoid that risk, okay, and the requirement over there. So hypervisor domain, students, we already discussed that it facilitates the resources of the compute domain to the virtual machine, okay, and it provides an abstraction of an hardware. So what are the security risks? Security risk is unauthorized access, okay, or the data leakage. Unauthorized access to the virtual machine or the data leakage is there. And what is the solution of the risk? So the solution is very simple. It's written that isolation of the served virtual machine space. It, the virtual machine has to be isolated from one another. Secondly, access provided only with authentication control. So whether it is from the guest user or so the access should be through authentication control. So student, next comes the computing domain. We will see what are the risks involved and what are the solution for the risk and the requirement for the security risk. So computing domain, we already discussed in a few slides before. It consists of the computing hardware and the storage hardware. So computing domain provides commercial off-the-shelf high volume server and the storage. The security risk to the high volume server and storage are the shared computing resources, like the CPU is shared, memory is shared, and so on. What are the solution for the security risks? The first one, secured thread. We have to provide a secured thread. Students, we know that traditionally the processes which are heavyweight have a thread of control, and thread is the lightweight. So there is a program counter, one sequence of instruction that can be carried out at any given of time. So these threads should be secured. Secondly, private and shared memory allocation should be deleted, should be erased before reallocation. Before reallocation of the shared memory of the private memory allocation. Number three, data should be used and stored in an encrypted manner by which exclusive access is provided only to the VNF, whether it is switching VNF related to switching or routing or IDS, IPS, whatever it is. Now let's go for the third one is the infrastructure domain. And student, as we discussed in the infrastructure domain, it comprises all the generic high volume switches interconnected into a network that we configure to supply the infrastructure network services. So what are the risk, please, security risk when we talk about infrastructure domain? So shared logical network layer like the virtual switches. So the virtual switching. So let's draw it first of all. Then if we have one virtual machine over here, this is one virtual machine with one VNF, other virtual machine. So these virtual machine have virtual NIC card because it's a virtual machine, student. Okay, and these can be connected to through our virtual switches, V switches. Here is virtual NIC card or physical NIC card, whatever it is, connected to our virtual switches. So what are the risks? Shared virtual switches here and physical NIC card or the virtual NIC card. This is the security risk at this point. So what is the solution to secure? It is using TLS, okay, transport layer security, or IP security, or SHH secure shell. So these are the security techniques for the infrastructure domain. So now students, it ends. So students, what we have covered so far in this lecture, we discussed about the NFV security. We discussed about the NFV security and attack surface. In NFV security, we discuss about what about the security challenges with NFV that increases the attack surface and increases the security complexity. Then we discuss about the attack surfaces. The attack surfaces. In attack surfaces, we discuss that attack surface is the sum of all possible security exposure. We discuss about the attack vectors like compromised credentials, weak and stolen credential, man in middle attack, all we discussed. Then we discussed about the ETSI security perspective. We discussed like a generic virtualization threat, generic networking threat, and NFV specific threats. Then at last we discussed about the hypervisor introspection. And in hypervisor introspection, we discussed about the hypervisor capability. It has to monitor each guest operating system or guest virtual machine for security purpose. And last three techniques, security techniques for the computing and hypervisor and infrastructure domain we discussed. So we discussed each, like in computing domain, what are the risks and what is the solution of the risk. So the risk and the solution of the risk was discussed. Similarly, in hypervisor domain, the risk involved and the solution of the risk that are there. And similarly, in infrastructure domain, what are the risks and what is the solution of the risk? Like we discussed, like SSH is the solution, SSL is the solution. Okay. So best wishes students. So if you have any query, please feel free to contact, inshallah, and stay safe. Best wishes. Assalamu alaikum wa rahmatullah wa barakatuh.